Large language models are the systems behind modern chatbots, translation tools, and many of the AI applications we see today. To understand them, it helps to look at what they are, how they work, what they can do, the benefits they bring, the risks they pose, and where they are heading in the future. At their core, large language models are built on a type of architecture called the transformer. This design allows them to process text by paying attention to context, not just individual words. They use mathematical representations called embeddings to capture meaning, so words with similar meanings are placed close together in a kind of map. Training these models involves exposing them to massive amounts of text so they learn patterns of language. After this pre-training, they can be fine-tuned for specific tasks, and in recent years, reinforcement learning from human feedback has been added to make them more aligned with human expectations. The combination of architecture, training methods, and enormous datasets is what gives these models their power. The applications of large language models are already widespread. They can generate text, answer questions, translate languages, and summarize documents. They are used in customer service chatbots, in tools that help programmers write code, and in systems that assist researchers by scanning and condensing large volumes of information. They also extend beyond text. With multimodal capabilities, some models can handle images, audio, and even video alongside language, opening up new possibilities for creative work and communication. LLMs increase productivity by automating repetitive tasks and speeding up workflows. They improve accessibility by helping non-native speakers communicate or by supporting people with disabilities through voice recognition and text-to-speech. They also enhance creativity, acting as collaborators that can suggest ideas, draft content, or generate designs. In many fields, from healthcare to education to entertainment, large language models are becoming valuable tools that expand human capability. But with these benefits come risks. Because they learn from data, they can also reproduce the biases present in that data. This means they might generate unfair or discriminatory outputs if not carefully managed. They can produce misinformation, generating text that sounds convincing but is factually wrong. Deepfakes and synthetic media raise further concerns about trust and authenticity. There is also the issue of job displacement, as tasks once performed by humans can now be automated. While new opportunities will emerge, the transition can be difficult for workers whose roles are affected. This is why regulation and ethics are so important. As these models become more powerful, society needs rules to ensure they are used responsibly. Questions of transparency, accountability, and fairness must be addressed. Governments and organizations are beginning to draft guidelines for how AI should be developed and deployed. Regulation will need to balance innovation with safety, encouraging progress while protecting people from harm. Ethical frameworks will play a key role in shaping how these systems interact with society. Looking to the future, several trends stand out. Models are becoming multimodal, able to process text, images, and sound together. Robotics combined with AI will bring language models into the physical world, enabling machines that can interact with people more naturally. In education, AI will personalize learning, giving students tailored support and teachers new tools. At the same time, researchers are working on smaller, more efficient models that can run on personal devices, reducing the need for massive computing resources. The debate between open and closed models will also shape the future, as communities and companies decide how much access to provide. Large language models are moving from being tools we use to being partners we collaborate with. They are changing how we communicate, how we work, and how we think about creativity and knowledge. Their future is inspiring because it points to a world where machines help us solve problems, expand imagination, and improve quality of life. But it also challenges us to think carefully about ethics, jobs, and human values. The story of large language models is not just about technology, it is about how humanity chooses to guide and integrate them. Artificial intelligence is evolving quickly, and large language models are at the center of that evolution. By understanding their foundations, their applications, their benefits, their risks, and their future directions, we can appreciate both their power and their limitations. The next decade will show us whether we can harness this technology to build a smarter, fairer, and more creative world. To understand how LLMs work, it helps to look at their technical foundations. These foundations include the architecture that powers them, the methods used to train them, and the role of data scale and quality. The architecture most commonly used today is called the transformer. Before transformers, models struggled to handle long sequences of text efficiently. Transformers introduced a mechanism called attention, which allows the model to focus on the most relevant parts of the input when making predictions. For example, if you ask a model to complete a sentence, it doesn't just look at the last word, it considers the entire context and decides which words are most important. This is why transformers are so good at capturing meaning in language. Embeddings are another key part of the architecture. An embedding is a way of representing words, sentences, or even images as numbers in a mathematical space. Instead of treating words as isolated symbols, embeddings capture relationships between them. Words with similar meanings end up close together in this space. For instance, king and queen are related, and the model can even learn analogies like king is to man as queen is to woman. Embeddings give the model a rich understanding of language that goes beyond simple word matching. Training methods are just as important as architecture. Large language models are first trained through a process called pre-training. In pre-training, the model is exposed to massive amounts of text and learns to predict missing words or the next word in a sentence. This builds a general understanding of language. After pre-training, models can be fine-tuned, which means adjusting the model on smaller, specialized datasets so it performs well on specific tasks, like medical text analysis or legal document review. Another training method that has become very influential is reinforcement learning from human feedback. Instead of just learning from text, the model is guided by human preferences. People rate the quality of the model's responses, and those ratings are used to adjust the model. This helps align the model's behavior with what humans actually want, making it more useful and safer. Reinforcement learning from human feedback is one of the reasons modern language models can produce answers that feel natural and helpful. Data scale and quality play a huge role in performance. The more data a model sees during training, the better it becomes at capturing patterns. But it's not just about quantity, it's also about diversity and quality. If the data is biased or full of errors, the model will learn those flaws. If the data covers many topics, styles, and languages, the model will be more versatile. For example, a model trained on billions of sentences from books, articles, and websites can handle everything from casual conversation to technical writing. On the other hand, if the dataset is narrow, the model's abilities will be limited. The scale of modern training is enormous. Some models are trained on hundreds of billions of words, requiring powerful computers and vast resources. This scale is what allows them to generate coherent essays, translate languages, and even write code. But it also raises questions about efficiency and sustainability, since training consumes significant energy. Researchers are now exploring ways to make models smaller and more efficient without losing capability. Combining transformers with attention mechanisms, embeddings that capture meaning, training methods like pre-training, fine-tuning, and reinforcement learning from human feedback, and the massive scale of diverse data, you get the large language models that are transforming technology today. They are not magic, but the result of careful engineering and enormous effort. The architecture explains why models can handle complex language. The training methods show how they adapt to human needs. The data scale and quality remind us that the output is only as good as the input. Together, these elements define what large language models can do, and they set the stage for future improvements.
If you find this video exciting, please like, subscribe, and turn on notifications. See you in the next AI for Beginners educational video.